Okay, so let's do problem 42, trapping rainwater, and in this question we are given an array of height of columns. So we can see that we have 0, 1, 0, 2, so 0, 1, 0, 2, and what we need to return is the amount of water trapped between pillars. So we can say there's 1, there's 1, there's 1, 1, so there are 5 of them, and there's another one here. So we have to return 6 as an output. So when we look at it like this, it's quite difficult to understand. So let's start with the very simple example and slowly build up our logic. So suppose we have the small pillar here and then the tall pillar here. And we do know that the amount of water that can be trapped is only 1. The reason is the amount of water that is trapped is bounded by the smaller pillar. So then what happens if we have another pillar here? We do know that it's going to be bounded by the smaller of those two pillars, which will be this one. So the amount of water that's going to be trapped will be 3 in this case. So what's the logic? Well, what we can do is we can get the tallest pillar on the left. Okay, let's say not tallest pillar, but the max pillar on the left. And then we get the max pillar on the right. And then we have to find the minimum of those two. So that's going to be 2, that's going to be 3, so the minimum would be 2. And what we need to do is we have to do 2, whatever is minimum, minus the height of each pillar. So it's going to be 2 minus 2, which will be 0. So 0 water is trapped here. 2 minus, there's a height of 1, so it's going to be 1. 2 minus 0, it's going to be 2. 2 minus, so that is slightly tricky. It didn't really work out as we expected because we got the minus value. So how can we prevent this? Well, what we can do is we can do something like this. Okay, so we have max left and right, they will be an array. So as we go from left to right, we we carry on the max height. So as we go from left, it's gonna be the max pillar will be 2, and then when we get to the next one, it's still gonna be 2, and then when we go to the next one, it's still gonna be 2, and when we go to the next one, it's gonna be 3. So the array will be 0, it will be 2, 2, 2, 3. And then we're going to do the same thing from the right to left. So it's going to be 3, 3, 3, 3. Alright, so what we're going to do is we're going to do the same thing. We're going to compare each of them. And then do the same thing. So we're going to apply whatever is minimum between max left I and then max right I, and we're going to subtract the height I. So if we do that, so I'm going to quickly work out the minimum. So the minimum will be 2, it will be 2, it will be 2, and then the minimum for here, it will be 0. Oh, it will be 3. And then if we subtract the height I, so height I, the height would be 2, 1, 0, 3. So if we subtract them, we get 0, so that will be 0. And then that will be 1, so we have 1 as expected, and then that will be 2, and then when we get to the last one, we are going to get 0 as we want it. So that's the logic we're going to use it, and then let's see how we can implement in our code. So we do need the max length and max right array. So int max left equals new int. What's the size going to be? Size is going to be the length of height. So we can just say int length equals height dot length. And then we do need one for max right as well. And then we do need another variable that stores the amount of water trapped. And then what we're going to do is we're going to get the max left. So for int I equals 0, I is less than length, and then I plus plus. And what we do is how do we update the max left? So how did we update the fourth one? So we compare with the max left on the one before with the current height. But when we do the first one, there isn't any value behind this, so we can actually start with I equals 1 and then initialize max left, the first element, with the first height, because it's going to be the maximum anyway, because there's nothing to compare. Likewise, the farthest one on the right will be the maximum value when we look at from right to left. So next right, it will be length minus 1 is equal to height length minus 1. And the logic is if max left dot 0 dot I is less than let's say it's greater height dot I. No, it's if the one before max left minus I minus 1 is greater than the current height, we say max left I is equal to max left I plus minus 1. Otherwise, meaning if the current height is greater, we can say max left I is equal to height dot I. This one is a bit too long, isn't it? So what we can do is we can just use max left dot I is equal to math.max, whichever is greater. So we're comparing max left dot I minus 1 with the current height. Okay, so that's it. That's initializing the max left, and then we have to initialize the max right. We are starting from the second last one, so it will be I is length minus 2, and then I is greater than or equal to 0, and I minus minus, and max right, we are going to do the same thing. Will be I is equal to max right I plus 1, because we're comparing the one before with the current height. So that's max right initialized, and then we have to carry out this formula we have. And so we're going to do for int I equals 0, I is less than length I plus plus. What are we going to do? We are going to do water trapped water is equal to trapped water plus so math.min max left dot I max right dot I, and then we have to take away the current height, and then we have to return trapped water. Let's see, max height we initialized, max height we also initialized, we correctly, let's see, max, comparing the one before with the current height, comparing the one before with the current height as well. Okay, let's run the test. It's passed, let's submit. Good, it only bit 69%. The reason is there is actually another solution. This has time and space complexity of O of n, but there is a time complexity of O of n, but space complexity of O of 1. So yeah, I'm gonna make the second video for the other solution. All right.